Our video today is going to take us through polygons. We're going to identify them, and we're also going to look at some special polygons which we will call quadrilaterals as we move through. So let's define a polygon. A polygon is a many-sided object, 3 or more sides, has straight edges, and as you can see in the diagram, there are a bunch of them that we're going to work with. And these are the ones that we're going to take the most time with in this section. You also notice it says regular polygon at the top. A regular polygon means that all sides are equal. So in all of these. So here's the chart that you will have with you as you watch the video. And you're going to be required to complete this chart as you go through this video with me. I'm only going to do a few of them and you can finish the rest of them. Yes, you're going to have to do some drawing, but that is something that is a part of geometry that you need to get good at. So let's talk about a couple other terms here, and that is a vertice. A vertice is simply a corner. So when we talk about a corner, we're just talking about these little things here, and that is a part of your polygon. The other thing is a diagonal. Diagonal is a straight line that connects two opposite corners. So when we draw our diagonals, we're going to start off in one vertice, and then we're going to go to the other one. And we're going to draw our straight lines, or segments in this case. So what we're going to do is we're going to take and go from one vertice of each of these polygons, and I'm only going to do a couple of them just to show you what you're going to do. And from there, you're going to continue the process. So we're going to start with one vertice, and if you notice in a triangle, it doesn't really work. Because what we cannot do is we cannot overlap what we've already done, and we can't cross, or not cross, but the overlapping is a part of it. So in a triangle, we really can't go anywhere. So when we deal with a triangle, we create no diagonals, but we do create a triangle, and that's what we want to deal with in our triangles, because if I add up all the angles in a triangle, we get 180 degrees. So as a part of this, we end up with one triangle, 180 degrees. So, but no diagonals. So now in a quadrilateral, which we have a four-sided object here, again, we're going to go from our one vertice. We can go across and hit that one. So that creates one diagonal, but we create two triangles. Well, two triangles is just doubling 180, so that gives us a total of 360 degrees. So all the angles in a quadrilateral, if I add them up, equal 360 degrees. So if I do a pentagon, and that's the last one that we'll do with you, and you have the rest of it to go through the chart. So again, we're going to start from here, and we can go to this corner, and we can go to this corner. And that's it. So we create two diagonals, but we create three triangles. If we take that times our 180, that will give us a certain amount of degrees, which in this case is going to end up to be 540 degrees. So I'm going to let you take care of the rest of these. So let's go and get to the chart of how you're going to fill this out. So as you fill this out, what you're going to do is you're going to complete this part. That one's pretty easy. You're going to complete this column. Again, easy. We've done number of diagonals in a triangle, which we said was 0. We did the ones in quadrilateral, which is 1. And at a pentagon, we came up with 2. So we created one triangle, because we had to draw a triangle in this. Quadrilateral, we created 2 triangles. And in a pentagon, we created 3. So we started out saying that 180 degrees is all the 3 sums of the angles if we add them up in a triangle. We doubled that, and we went to 360 for a quadrilateral, and we had 3 of them here, which gave us 540. So what I'd like you to do is continue through this and finish this up. Now, we're going to take this just a different twist, so again, you're going to have to draw these out again. But what we're going to do next is we're going to look at it from all vertices. So now we're going to go around the object and see how many total diagonals we can do from all the vertices. Again, I'm only going to do a few of these. I'm going to require you to do the rest as a part of your notes in this section. So again, we start off with a triangle. We can't draw any diagonals, so again, our number is 0 for this. And all we're looking for in this case is just the diagonals in this part. So if we go to the quadrilateral, we can go here. I would suggest getting yourself some colored pencils, because when you change the vertices, You want to change color so you can actually see them. And again, we can go here. We cannot go to this one up here and go across because we've already done that line. We cannot go here because there's already a segment drawn, and same with here. So we can cross them, we just can't overlap them. So in here we ended up with 1, 2, so our answer would be 2 for that one. So again, I'll do the pentagon again. So if we start off in this corner, we go here, we go here. I'm going to change color, I'm going to rotate, go here and go here. And I can go one more place because that's the only one that's left. And again, colored pencils help because then I can see that I created a total of 1, 2, 3, 4, and 5 total diagonals. So again, I'm going to have you go through the rest of these. As you can see, these two, get to the last column on your chart. So on this column, this is where you're going to fill in your information. So again, with a triangle, we created 0. Our quadrilateral, we created 2. With our pentagon, we created 5. So your job is to finish this up in regards to that. Our next section is on special polygons, which we're going to look at quadrilaterals. But special polygons are polygons that have certain things that pertain to specific polygons. In this case, are quadrilaterals. So we're going to look at angles, we're going to look at sides, and we're going to look at degrees. So we're going to create a little bit of a little web here to help you out in regard to that. So each one of these has their own specific way of identifying what you're looking at. So when we talk about a square, we talk about that all angles are right angles and all sides are equal. With a rectangle, we say that all angles are right angles and all diagonals are equal length. So when we talk about diagonals, we're talking about these. These are equal in the length that you draw them. You also have two sides, this side and this side, that are parallel to each other, and you also can say that this side and this side are parallel to each other. With a rhombus is a little bit different. Oops, sorry about that. A rhombus is all sides are equal. The diagonals bisect opposite angles, and what we mean by that is if you look down in this diagram here, this is what we're talking about in regards to bisecting with the diagonal. So we're cutting the angle in half. The diagonals are perpendicular to each other, so in my drawing here, you can see the right angle symbol, and they are perpendicular to each other. For a parallelogram, both pairs of opposite sides are parallel. Both pairs of opposite sides are equal. So if we identify that, this side is equal to this side is equal to this side. Trapezoid, unique little drawing. Only one pair of sides are parallel, and that would be these two. Parallel sides are the bases, so it's kind of what it sits on. And non-parallel sides are the legs. Our last diagram is what's called a kite. I have one bit of information for you on this one, and that is two pairs of sides are equal. So you can see by the identification that these are equal to each other for the sides. So to the web, and what we're going to do is we're going to just have a little fun with this one first, and that's why the title is here of cats, dogs, and mice. So what we're going to do is we're going to call this, instead of quadrilaterals, we're going to say that these are animals. So these are going to be our dogs. This is our cat, and this is our mice, or mouse. Now, with dogs, we can get different breeds of dogs. So the dog that we're going to work with today is a poodle and a boxer. What we're going to do is combine those two together, and we're going to get what we call a boodle. Okay? So now, with this chart, there is directionality for this. So just a couple things. This is where it gets a little confusing, so you got to really pay attention to the question and what they're doing. Is we can say that every boodle is an animal. Well, if I look at this, a boodle is here, and it's under animals, so that would be correct. I can say a dog. Every dog is an animal. So I'd start here and here. Every dog is a boodle. So that means that I'm going from here to here. That doesn't work because I know that it can be a poodle and it can be a boxer. Every animal is a cat. And again, that's not true because it can be a cat, a dog, and a mouse. Every poodle is a dog. Every poodle is a dog, and it's also an animal. Every cat is an animal. That works. So hopefully you're getting a chance to see there is some directionality of what always works, and that's always going up. And maybe sometimes going down. So get into the meat and potatoes of the business side of this one. So now you can, if you want, you can say that this is a parallelogram, this is a rhombus, this is a rectangle, and this is a square. This is a trapezoid, and this is a kite. So now you can identify those again if you want to put those in with the animal ones that we just did. Here's where it gets confusing. And these are some of the examples that you'll see as type of questions. My suggestion would be to write these down in your notes, keep a database of them so you can see this, because they'll start looking the same. So we're going to use our little grid or our little web that's up here, and we're going to answer these three questions. So the first question is, every square is a rectangle. So what you're going to do is you're going to go from the first word, this is where you're going to start on the web, and it's going to take you to that one. So we're going to start at a square, and we're going to go up. As long as you go up, it will always be true. So if we go to the second one, every rectangle is a parallelogram. Again, we're going to start with a rectangle, and every rectangle is a parallelogram. So again, that would be true. So again, we're starting here, and we're going to this one. The last question is, every parallelogram is a rectangle. So every parallelogram is a rectangle. Well, that one comes out to be false because we went in a downward direction. So when we do this, up always works, down sometimes. So this is always, this is sometimes. The big word here is every. So as you go through this, use your notes, use what you're going to be doing, create a drawing, cut things out, ask questions to make this section go by a lot easier.